Hello everyone. Today we will cover section 11.4 non-linear inequalities in one variable. So for example, if we have this inequality x squared plus 7x plus 12 greater than or equal 0. This is an inequality in one variable. Now to solve a quadratic inequality, so first set the inequality to 0. Set the inequality to 0. So here we set the inequality to 0. X squared plus 7x plus 12 equals 0. Second, factor the inequality. So factor this inequality. So here this inequality or this, now this becomes an equation now. To factor this equation by trial and error, so x squared is x times x. So here the sign for the last term is positive. So the sign for the binomial is the same like middle, positive, positive. So now find two numbers whose product is 12 and whose sum is 7 is 4 and 3. Let us check. The inner product is 4x. The outer product is 3x. So 4x plus 3x equal the middle term, which is 7x. So now, by zero factor property, x plus 4 equals 0, or x plus 3 equals 0. So from this equation, x equals negative 4. From this one, x plus 3 equals 0, we get x equals negative 3. These two values are called critical numbers. So find the critical numbers for the solution set. Set the factors equal 0 and solve. The graphs of these critical values establish the three intervals on the number line. So if we graph these two numbers on the number line, this is the number line. So if we graph x equal negative 4, x equal negative 3, so the number line divided into three intervals. The first interval is this one, from minus infinity to negative 4. The second interval is from minus 4 to negative 3. And the third is from minus 3 to infinity. So at negative 4, we will put closed circle. Similarly at negative 3, because here the inequality we have greater than or equal. So if the inequality is greater than or equal, less than or equal, we put the closed circle. If we have greater than or less than, so we graph open circle. So now, to determine which intervals are solutions, we test a number in each interval and see whether it satisfies the inequality. So now we have these three intervals. To check which of these three intervals are a solution, so choose any number belong to this interval. From minus infinity to negative 4, you can choose x equal negative 5. So here x equal negative 5. Now the inequality is this. This is the inequality. X squared plus 7x plus 12 greater than or equal 0. So substitute x equal negative 5 in this inequality. So if x equal negative 5 squared plus 7 times negative 5 plus 12. Is it greater than or equal 0? So negative 5 squared is positive 25. 7 times negative 5 is negative 35 plus 12 greater than or equal 0. Simplify, so we get 2. Is 2 greater than or equal 0? Yes. So this means this interval is a solution from minus infinity to negative 4. Similarly, take any number belong to this interval from minus 4 to negative 3. You can choose negative 3.5. Negative 3.5 belong to this interval. Then substitute negative 3.5 for x in this inequality. So x squared or negative 3.5 quantity squared plus 7 times negative 3.5 plus 12. Is it greater than or equal 0? Now simplify. If we multiply negative 3.5 by itself, so we get positive 12.25. Then negative 7 times this number equal negative 24.50 plus 12. Is it greater than or equal 0? So we get negative number greater than 0, which is false statement. So now this interval is not a solution from minus 4 to negative 3. Similarly, let us check this interval. Is it solution or not? So from minus 3 to infinity, you can choose any number. Let us choose x equals 0. So 0 belongs to this interval. So now the inequality is this: x squared plus 7x plus 12 greater than or equal 0. So if x equals 0, substitute 0 for x, so we get 0 plus 0 plus 12. Is it greater than or equal 0? Yes. 12 greater than or equal 0. So this is a true statement. So now this is also a solution. Then grab the solution and give the result in interval notation. So now the solution is minus infinity to negative 4, brackets at negative 4 because here we have a closed circle, union negative 3 to infinity, brackets, parentheses. So now this is the solution. Let us take another example from the chapter or from section 11.4. Let us solve, for example. So this is exercise 6 on page 696. Solve each polynomial inequality. Solve each polynomial inequality. Write the solution in interval notation. Write the solution in interval notation. So exercise 6 is x squared plus 8x plus 15 greater than or equal 0. So this is the inequality. So first, set the inequality to 0. So now we have equation. Factor this trinomial, factor this trinomial by trial and error. So we get x times x. So here the sign for the last term is positive. So the sign for the binomial is the same like middle, positive, positive. So find two numbers whose product is 15 and whose sum is 8. So 5 and 3. Therefore, x plus 5 equals 0. So x equals negative 5. Or x plus 3 equals 0, so x equals negative 3. So now these 2 points are called critical numbers. The graph of these 2 numbers in the number line, this is the number line. The graph of these 2 points divides the number line into 3 intervals. So suppose this is negative 3, this is negative 5. So here we graph negative 3 to the right of negative 5 because negative 3 is greater than negative. So now we have 3 intervals. The first interval is from minus infinity to negative 5. The second one from negative 5 to negative 3. The third is from negative 3 to infinity. Now, since we have the inequality is greater than or equal, so we graph closed circle at negative 5. Also closed circle at negative 3. Now let us check which interval among these 3 are a solution. So let us choose one point belong to each interval. For this interval, you can choose x equal negative 6 because negative 6 belong to this interval. For this one, from negative 5 to negative 3, you can choose x equal negative 4. And from negative 3 to infinity, you can choose x equals 0. Choose the easier point. So here, let us check x equal negative 6, then x equal negative 4, then x equals 0. So we choose one point belong to each interval. Now the inequality is x squared plus 8x plus 15 greater than or equal 0. Similarly here, x squared plus 8x plus 15 greater than or equal 0. So now, let us start with x equals 0. So if x equals 0, so 0 squared is 0, plus 8 times 0, plus 15. Is it greater than or equal 0? So 0 plus 8 times 0 is 0, plus 15. Is it greater than or equal 0? So yes, 15 is greater than or equal 0. This is a true statement. So if it is true, so this is a solution. We accept this interval from negative 3 to infinity. Let us check if x equal negative 4. So if x equal negative 4, square plus 8 times negative 4 plus 15. Is it greater than or equal 0? Negative 4 square is 16. 8 times negative 4, negative 32, plus 15. Is it greater than or equal 0? So 16 plus 15 is 31. Minus 32, negative 1. Negative 1 greater than or equal 0? No, this is false statement. So now this interval is not a solution. Let us check if x equal negative 6. So if x equal negative 6, so negative 6 squared plus 8 times negative 6 plus 15. Is it greater than or equal 0? Negative 6 squared is positive 36. 8 times negative 6, negative 48 plus 15. Is it greater than or equal 0? Now 36 plus 15 is 51. Minus 48 is 3. So 3 is greater than or equal 0, yes. So now this interval is also a solution. Then now write the solution set is this one union this. So the solution now is minus infinity to negative 5 brackets parentheses union negative 3 to infinity. So we put brackets here because we have closed circle here. So negative 3 to infinity. This is the solution. Now let us go over the packet. We have this another example. So now this example contains a fraction. This inequality contains a fraction. So remember, critical numbers coming from a denominator are never part of a solution set. So first, set the denominator equals 0. So here x equals 0 is a critical number because we cannot divide by 0. So this is a critical number. Now second, apply the same procedure. So set the inequality equal to 0. So 4 over x equal 8. Solve this equation to find x. So use the cross product. So we get 8 times x is 8x. 1 times 4 is 4. Divide by 8. So we get x equal 4 over 8 or equal 1/2. This is also a critical number. So now we have two critical numbers. X equals 0 coming from the denominator and x equal 1/2. So the graph of these 2 points, x equals 0, x equal 1/2, divide the number line into 3 intervals. The first interval is from minus infinity to 0. The second one is from 0 to 1/2. And the third is from 1/2 to infinity. So here we put, at 0, we put open circle y. Although here we have greater than or equal. But why we put open circle? Because if we put closed circle, this means 0 is a solution. But 0 here is not a solution because we cannot divide by 0. We put closed circle at 1/2 because if x equal 1/2, so the denominator is different than 0. So we put a closed circle, all point we put closed circle except that makes the denominator equal 0. So here since x equals 0, so here we put open circle. Now let us check which of these 3 intervals is a solution. So now let us check a point. You can choose any point belong to this interval. So here we choose x equal -1. For this interval from 0 to 1/2, you can choose x equal 1/4. From 1/2 to infinity, you can choose x equal 1. Now let us check. X equal -1. The inequality is, this is the inequality, 4 over x greater than or equal 8. So if x equal -1, 4 divided by -1, is it greater than or equal 8? Or -4 greater than or equal 8? This is false statement. So now this interval is not a solution. Let us check if x equal 1/4. So substitute 1/4 for x. So 4 divided by 1/4. So here this fraction bar means division. So 4 divided by 1/4. Then 4 means 4/1. So change division into multiplication, then flip this fraction. So we get, now multiply nominators together and denominators together. So we get 16/1, which is 16. Greater than or equal 8? Yes. So now this interval is a solution. And similarly here, if x equal 1, so if x equal 1, this is the inequality. So 4 divided by 1, is it greater than or equal 8? So 4 greater than or equal 8, this is false statement. So this interval is not a solution. So the only interval is this one, is the solution. From 0 to 1/2. Parentheses, brackets. Let us solve another example from exercises 11.4. So exercise 16. This is on page 696. Solve each inequality then write the solution in interval notation. So exercise 16 is x minus 5 over x minus 6 greater than 0. So first, so here we know that dividing by 0 is impossible. So here first set the denominator equal to 0, then solve this equation. So x equals 6. So this is a critical number. Now, let us apply the same procedure. So first, set this inequality to 0. So x minus 5 over x minus 6 equals 0. So now we have equation. Solve this equation to find x. So use the cross product or multiply by x minus 6 both sides of the equation. So we get x minus 5 times 1, x minus 5. 0 times x minus 6 is 0. Solve this equation. So x equal 5. So add 5 to each side. So x equal 5 is also critical number. Now the graph of these two critical numbers in the number line. So we have 5 and 6. Suppose this is 5, this is 6. So the graph of these 2 points divides the interval into 3, or divide the number line into 3 intervals. This is the first interval, this is the second, and this is the third. Now, here we have greater than. If we have greater than or less than, we put or we graph open circle. So we graph open circle at 6, open circle at 5. If we have a greater than or equal, we will graph open circle at 6. Why? Because at 6. Because we know that if x equals 6, 6 minus 6, we get 0 in the denominator. So we cannot divide by 0. While we put at 5 a closed circle. Why? If we have greater than or equal or less than or equal, so we graph closed circle at 5, open circle at 6. Why here, in this example, we have greater than, so both of them is open circle. So let us check which interval of these 3 is a solution. So now, choose one point belong to each interval. From 6 to infinity, you can choose x equals 7. From 5 to 6, you can choose x equal 5.5. Then from minus infinity to 5, you can choose x equals 0. Choose the easier one. Now let us check. So x equals 0, x equals 5.5, then x equals 7. The inequality is, write the inequality here, this inequality. So x minus 5 over x minus 6 greater than 0. Similarly here, x minus 5 over x minus 6 greater than 0. Let us check the first one, when x equals 0. Substitute 0 for x, so we get 0 minus 5 over 0 minus 6. Is it greater than 0? Or minus 5 over negative 6 greater than 0? So negative divided by negative is positive. So 5, 6. Is it greater than 0? Yes, this is true statement. So now this is a solution. Let us check if x equals 7. So 7 minus 5 over 7 minus 6 greater than 0. 7 minus 5 is 2. 7 minus 6 is 1. Is it greater than 0? So 2 divided by 1 is 2. Also, this is true statement. So this is a solution from 7 to infinity. Let us check if x equals 5.5. So 5.5 minus 5 divided by 5.5 minus 6. Is it greater than 0? So here 5.5 minus 5 is 0.5. 5.5 minus 6 minus 0.5. Is it greater than 0? So here divide by 0.5. So we get negative 1. 1 divided by negative 1 is negative 1. Greater than 0? No. This is false statement. So this interval is not a solution. So now the solution is this interval union this interval. So now write the solution as an interval notation. So the solution is minus infinity to 5, minus infinity to 5, parentheses, union 6 to infinity. So this is the solution. Try to solve some exercises also from this section by a similar method. Thank you.